Hello, good morning, all dear students. How are you doing? Fine. So, all my future engineers and doctors, I hope you all are learning with me. You are enjoying your studies at home, right? Last time you have discussed lots of numerical problems, and I asked you people to do at your home also whatever the questions you are getting, and I hope some of you would have tried it. And if you have any difficulty, you can ask from me, right? You can write me the question number and I will definitely help you to solve those questions. Even after my session also, I can conduct one more session on the base of feedback that I will get from you. So wherever you find any difficulty, wherever you feel that you have some problem, right? You can call me, you can ask from me without any hesitation. Please feel free to write your problems in the live chat, as well as you can comment me, you can tell me, right? And definitely I will try to help you at my level best. So, kinetics, the two important questions. One question actually comes for the 5 marks, and it is always having the option. So the first option is always and always for the integrated rate law, right? And in the option of that, the question that comes is based on the effect of temperature on the chemical reaction. So that today I'm going to take. You have seen so many factors affecting to the rate of reaction in the beginning of the session, in the previous sessions, first and second session. I have taken the general session, and in that I have discussed the factors affecting to the rate of reaction. And if you remember, I have shown you the small activities also. The nature of reactant, that is one important factor that affect to the rate of reaction. Then you have seen the surface area. I have shown you the reaction for the powdered and the a chalk piece I have taken for the calcium carbonate. And the third, the very important one, the concentration of the reactants. And we have studied it in detail. In detail, we have studied the effect of concentration, the rate law, order, everything. It deals with that particular topic, the effect of concentration on the rate of reaction. Good morning, students. I can see you here. Bobo, Muskan, Soni, and Angel, all of you, good morning. And please stay tuned with me. One to one, we will do the practice. So now, two more factors are left, and these factors are the temperature and the another one is the catalyst. Two important things are there, right? And one by one, I'm going to teach you these two topics also. And with this, we will finish the chapter chemical kinetics. And I will come with another chapter also, don't worry. And I will try to make your summer vacation fruitful for you. I think it's a very common practice in the class 11th also. You have done some practicals, and most of the time you need to heat the reaction. Whenever you heat the reaction mixture, the reaction becomes fast. It proves that the temperature alters the rate of reaction, right? And why this all happens? Actually, you all know what is a chemical reaction. Chemical reaction is always the change in the bonding. What happens? The bonds between the reactant and reactant A2 plus B2 is equal to AB. If it is going to form, what will happen? The bond between A and B exist, right? And the new bond that is to be formed is the bond between A and B. And when this bond can be formed? only when if this bond is being dissociated, right? When this A and B free, then they are going to combine together to form the AB. That means always a chemical reaction involve two things. First is the dissociation of bond and the second is the formation of bond. You all know that dissociation of bond is always an endothermic process. You need to provide energy, and this is the process in which energy is released. Always the bond formation is exothermic. Now let's see how the temperature affects, right? For any chemical reaction, two things are very important, right? There are two hurdles mainly. Why any reaction cannot progress? One thing, one barrier is the first important barrier is the energy barrier, right? They must have sufficient energy so that these bonds can be dissociated. For the dissociation of these bonds, the bonds which are pre-existing, there must be sufficient amount of the energies, right? And the second barrier is the orientation barrier. Suppose you have to come to the school, right? You all how get ready, right? You all keep your books, bags, everything packed. Then two very important things are there. You must have sufficient energy to come to the school. Either if you are coming the bicycle or you are coming by the walk, then your body must have the sufficient energy. And the second thing, most of you opt the vehicles, right? Nowadays, especially the higher class students, they are always using the locomotives, bikes or the scooters, these. So you must have the sufficient petrol. Petrol is the form of energy that you are using. And the second important thing, you must know the way of the school. So two important things are there. Energy must be with you. Okay, that's why we always say, please take breakfast for the so that you are capable of enough for learning also. So two kinds of barriers are there. First barrier is the energy barrier. And the second barrier is the orientation. Suppose your school has to take the left turn and you have taken the right turn. Do you feel you would be able to reach the school? No. The orientation must be also correct. Right? In every chemical reaction, the collision between particles take place and by only the effective collision. All the collision cannot convert the reactant into the product. For that, collisions must be effective, and these collisions must be effective in two terms. First, in the term of the energy, they must possess the sufficient amount of the energy, right? And the orientation must be right. Suppose you have a lock, you are placing the key. If you are placing it inwards, would it work? No. So similarly, for the collision also, what it should be, it must be the right orientation. The orientation term we will study in the time when we are going to study the effect of catalyst in the chemical reaction. Now I am going to take the effect of temperature, right? So what you have seen, why you need the energy, you have all have seen that the temperature practically during the experiments in the lab, you have seen that if we change the temperature, the rate of reaction changes. Why this happens? Because of the energy barrier. Here we see the graph. Two graphs are plotted here. One by one I am taking both the graph. Right. Generally for dissociation of these bonds, a definite amount of energy is required. You can see this is the energy barrier, right? You all can see in the graph, right? For the reaction like this hurdle race. Some of time you must have participated in the hurdle race that is organized during the sports day. What happens there? There are some hurdles and you have to jump and then you have to cross, then you will reach to the next level. Right? Similarly here also this hurdle is energy barrier because you need this energy to dissociate the pre-existing bonds. Right? So here also, what you see that AB, if it is a reactant, right, all of its molecule, they do not have the energy equal to cross this energy barrier. This is the minimum amount of the energy. This is the minimum amount of the energy that every molecule must have. It's must that if you are having this much energy, then only the reaction can complete, the reactant can participate. Actually, what happens, intermediate compounds are formed, the transition states are formed by this change, right? And this amount of the energy, this is called the threshold energy. Threshold, a very common word. In your houses, the thresholds are there, and if you have to go out, you have to jump. What you have to cross that threshold, right? And similarly here, if you have to proceed a chemical reaction, this much amount of the energy is must to be possessed, right? So here this is the energy required, right? And most of the molecules, I'm not saying, some of the molecules may have the energy equal to this threshold energy. They will participate in the reaction, they will make the effective collision, and they will convert into the product. But all of the molecule, they do not have this energy. Their ground level energy is this. This is this energy that, suppose 50 molecules you have taken, 50 moles are there. Out of 50, 15 are having the energy equal to the threshold energy. Now you have provided energy. It may be in the form of heat, it may be in the form of radiation, temperature. So what they will do? They will absorb the energy from here, and now if the sufficient energy is given, okay, so they may reach to this energy level. And now they can cross this energy level, they can participate in the reaction, right? This extra energy, this was the ground level energy, and this is the energy that we require here, right? This energy, the difference between the threshold energy and the ground level energy or the normal energy that a molecule possesses is the energy of activation, right? They were present in the reaction mixture, but they were not activated. How they have become activated? When they have absorbed the energy, right? By absorbing the energy, what they have done, they have become excited, they have become active, and now they are going to convert into the product. You can see a fall over here, right? Why? Because when the molecule is going, when reaction is going to complete, when a molecule is going to form the new bond, it will release some energy and its energy will be lowered down. I think you must all have seen how the tea is made. What happens? You take some of the reactants of the tea, that I can say milk, tea, water, sugar, and if you keep it like this, do you feel the tea will be prepared? No. What do you all do, or your mothers or your family members do? They keep it on the flame, right? And after a definite temperature, it starts boiling. For that boiling, you all need to switch on your gas stoves. You have to heat your reaction mixture, right? This happens over here also, right? Reactants are mixed, but they are not going to convert till they are not boiling, right? So for this purpose, what you need, you have to switch on your gas stoves. That means you have to heat it. Now, I think at one temperature, the tea starts boiling. What everybody do? They just lower the flame. What they do, they lower the flame, and by that the temperature is lowered down. And do you take the sip immediately as it boils? No. You just allow it to cool for few seconds, few minutes, and then only you can enjoy the cup of tea. You can sip the tea with the taste. Otherwise, your tongue is going to be in the trouble. Similarly, here also takes place that what happens, the reactant, they go to the maximum level. Whenever the energy you are providing, right, this energy is absorbed by the more number of molecules. 15 earlier, the number of molecules were participating was the 15. Right. Now, what has happened? Some more molecules, suppose now 30 molecules are part, they have absorbed the energy and they are participating in the reaction. So definitely now the more number of the molecules are going to react here, right? And what has happened, more number of the molecules, since they are reacting, the rate of reaction will be more, as the reaction depends upon the concentration or the number of molecules which are actually participating. This is the rule. What is the energy of activation, EA here? Right? The difference between the ground, this entire energy is the threshold energy. Right? The difference, right? This entire energy is not the energy of activation. Okay, like if you want to start a business, okay, you need the 2 lakhs, already you have the 1 lakhs, and how much short you have? 1 lakh. If someone else provides you the 1 lakh, okay, now you will have the 2 lakhs and you can start your business. So this complete 2 lakhs is the threshold energy, and this 1 lakh already you were having, that was your ground state energy. And after that, you have been given 1 lakh by someone else, that is the energy of activation. You were having the caliber, you were having the potential, but still you were not in the state to run your business. Just by getting that extra chunk of the sum, rupees 1 lakh, what you have done, you are in the state of running your business. So here also the difference between the threshold energy. Now I'm just going to rub it. So please note it down with me. This formula you need here. Energy of activation represented by EA. This is we are going to use in the Arrhenius equation. Just now I'm going to derive. Right. This is equal to threshold energy minus ground state or normal energy. Right? Difference of the energies is the EA. Please, by seeing the graph, can you tell me which one is drawn for the endothermic, which one is for the exothermic? See here, this is the reactant energy, this is the product energy. The energy of the reactant is less than the product, or I can say the product energy is more and the reactant energy is less. It has absorbed 50, right? Out of that 30, still it holds only 20 it has released. That means still the 30 kilojoule energy is consumed here. This is for the endothermic process. The reaction in which the product energy is greater, always that is the endothermic. Here you can see once the reaction started, now the energy of the product is very less than the reactant. That means up to how much you have given, it has came here. You can see here, right? And now this is the extra energy that it has released, right? So this is for the exothermic process. By seeing the graph, you can come to the conclusion, and this one is for endothermic. Otherwise, I need not to draw two graphs. Why? I have done this much work just for you guys. And you know, your likes, it catalyzes me. As many likes as you are going to give me, more I'm going to be excited, and more energy of the activation I will have, and more work I will do. I will do more and more work for you people. So if you feel that classes are productive, please do likes, right? Definitely always this kind act na, it gives the motivation, because by this we come to know that you all are learning. And if the classes are not for the learning, we don't feel that energy. So this energy, this is the energy of activation. This effect, two quantities are there. One is the temperature coefficient, that also I just want to tell you here. Temperature coefficient, it is one parameter, right? In the temperature coefficient, what the rate of reaction at given temperature, right, or 10 degree plus, and rate at 273 Kelvin. Right. This is a comparative. This is the quantity by which we can compare, right? You all can see the rate of reaction at the 273 degree, and here if suppose you have increased the temperature by the 10 degree, what if you are going to see? Mostly it is the temperature coefficient is between 2 to 3. Whenever you raise the temperature by the 10 degree, the generally rate of reaction, it increases by the 2 to 3 times, not more than 3. Actually, two things are there by providing the energy of activation. First, the number of reactant molecules, the reaction coordinate increases. The second, kinetic energy of the molecules also increase. They now move with the faster velocity. If the velocity is fast, definitely the probability of the collision will be also higher, and more collision, more possibility for the completion of the reaction. Now, I am coming to the Arrhenius equation, the very, very important one for the numerical purpose, for the numerical questions. The effect of temperature quantitatively, right? It was given by the Arrhenius equation. Actually, this equation was first given by the Van 't Hoff, but he could not produce the experimental evidence, and science never completes without the evidence. So that's why the credit has been given to the Arrhenius. Otherwise, first of all, this equation was given by the Van 't Hoff. Now, see how. Please, now I request to use the pen and paper. Every time I say that, please use the pen and paper. That is very, very important. Especially derivation and numericals you cannot do. Arrhenius equation. I think my time is changed today. That's why the number of students I can see very less. I have changed the time, and because of that, maybe you are not properly informed. Tomorrow also my class will be at 10 only. Just inform to all the other students also. Arrhenius, how he has given the reaction, he has related the energy of activation with the rate law. You all know that rate law is specific for any quantity if the temperature remain constant. This sentence I have spoken when I was comparing the rate of reaction with the rate constant. I said at that moment, for any particular reaction, the rate constant does not depend upon the concentration, but temperature must be constant. And here, since we are seeing that temperature is varying here, the rate, the constant will also change. And you all know that now rate is equal to K a to the power x. So if it is constant, This will increase, definitely this will also increase. So if I am observing it in the terms of K, definitely the same is result for the rate of reaction also, right? So now what is the equation, how it is given? The K rate constant is equal to e to the power minus a e to the power minus EA upon RT. Here K is the rate constant. A, it is the constant that is called frequency factor also. This is the frequency factor. A, probability, pro exponential, so many names are given to this factor, right? Arrhenius factor also a very common name for this. This is dot, that means multiplied. It's an exponential. E is the exponential, right? And minus EA upon RT. This is the power, right? This is the Arrhenius equation. Now I'm taking the logarithm of both the sides of the equation, right? Please take the log. What you have to do, take the log K. This is equal to, don't worry, a very simple formula. Immediately at this place only, I will tell you log A. Now what to do? I think you all have seen that log A into log B is equal to log A plus B. Similarly, log A plus log B is equal to log A into B. The same is for the division and the subtraction. Here, what you are going to do here, log, these quantities are in the multiplication, so you will do the plus log of, I'm writing in the bracket, it has the meaning, e to the power minus EA upon RT. Purposefully, मैंने पहले भी कहा था, I don't speak any word without any purpose here. So here, one very important thing here, one formula I just want to tell you here about the logarithm. Log a to the power x, this is always equal to x log a. It's a property of the logarithm. The same thing we can do here. Log k is equal to log, natural log I have taken till now everywhere, a plus minus, the power is in the minus, here the x is in the minus. If you compare here, this will be minus EA upon R is the gaseous constant, very important, and T is the temperature in the Kelvin. The one very important thing about the gas constant I want to say, here it is the energy. That means energy will be in the joule. What will be the unit of energy? It will be in the joule. So definitely you have to take the value of R also in the joule. There are so many values of the gas constant. Which one is best suited, that you have to see in the equation. Since it is with the energy is always expressed in the joules. This is to be taken into the joule, right? And per Kelvin you are taking, that's why the temperature must be in the Kelvin, capital T I have written here, right? Now log E. The value of log E is equal to 1. So what you can write here? Log K is equal to log A minus EA upon RT. This is the basic equation given by the Arrhenius. This is original Arrhenius equation. Now, what is your objective to learn here? Your objective is that you want to study what is going to be the effect of change in the temperature. That means, suppose initially the temperature is 273 Kelvin. Now the temperature become 283. What will be the change here? Right? So you want to compare the rate of reaction at two different temperatures, right? So I'm converting it into that form, right? Please, if you have not noted, take a screenshot. K is equal to A dot e to the power minus EART. This comes from the gaseous equation, kinetic equation of the gas. You need not to derive here. You have to directly use it, right? Now I have taken the logarithm of the equation. Any property, if you have to use in the equation, it should be equally used in both the sides. So I have taken the logarithm of both the sides. Log a is equal to log a plus log, this is the property of log a into b, that log a plus log b, right? Whenever you are taking the logarithm of a into b, this becomes log a plus log b. Here, simple for the bio students, need not to be worried, right? You don't need to be worried here at all. Log e to the power minus EA upon RT. Now, this is the formula that I have applied here. Log a to the power x is equal to x log a. The same formula is applied here. Then log e, the value of exponential logarithm is the 1, right? And that's why this is the value over here. Is it clear? Now, shall I rub this part? Okay. Please note this equation. You have to draw the graph. And the same I am going to use for comparing with two different temperatures, right? What is the basic equation I have derived? Log K is equal to log A minus A, Arrhenius factor, frequency factor, minus EA upon RT. EA is the energy of activation, right? Suppose whenever the temperature is T1, right? Initially, you are comparing at the rate of reaction at two different temperatures. Initially, the temperature is T1, right? At this time, the rate of reaction, the constant is K1. You can write it like this. All other are the constant. For a particular reaction, the value of EA is also the constant one, right? So this will be also constant. Suppose now the temperature is changed to T2, the rate of reaction has become K2, constant has become K2. Log K2 is equal to log A minus EA upon R T2. This is the equation number 1. This is the equation number 2. Right? For the temperature T1, this is for the temperature T2. You have to study the effect, what the difference has been caused in the rate of reaction, and for this you want to know the difference between the rate at T2 and T1, right? So what you have to do, you have to subtract. Simply what you have to do, you have to subtract. So log K2 minus log K1, right? Please use the pen paper. Simultaneously, simple plus minus करना है हमको. Okay, you must have to do the plus and minus only, and I know you all can do this very nicely, very easily, right? करना क्या है भाई, आपको डिफरेंस ही तो निकालना है. डिफरेंस के लिए एक ही प्रॉपर्टी है, क्या कर दें हम इसको माइनस कर दें, राइट? सो इफ आई हैव, और एक साइड तो माइनस कर नहीं सकते, कोई भी इक्वेशन है तो दोनों साइड्स को इक्वली यू हैव टू सबट्रैक्ट, right? So what I am going, and here you can see that if I am going to minus this, I have to inform this. Log A will be common, right? Log A EART2 minus this one. So this log A will be cancelled out. Dear students, this will be cancelled out. So why to carry the garbage? I don't like actually to carry the garbage with me, and that's why what I'm going to do, I'm just going to leave this packet here only. Okay, dustbin, use it, dump it. Now it's of no use. So what I have to do here, I'm just taking this side, minus EA upon R T2 minus the entire quantity is in the minus. Don't forget to you make the proper use of the sign. Right? What it is going to be here? Minus EA upon R T1. Right? Minus minus plus. Right? So log, this is again the property of the log. Log A minus log B is equal to log A upon B. The same property I am going to apply here. Log K2 upon K1 is equal to माइनस माइनस प्लस प्लस को पहले लिख दिया, अच्छा नहीं लग रहा पीछे, माइनस पहले, निगेटिव इज ऑलवेज द सेकेंड, पॉजिटिविटी मस्ट बी द फर्स्ट थिंग, राइट? सो पॉजिटिविटी, the positive quantity, that is the EART1, I am taking the first. Don't always be positive. This positivity is the biggest strength of anyone. With this positivity, hopes and the dedication, you can do the miracles, right? Whenever we become negative, automatically our zeal, our enthusiasm, our energy, it becomes negative, and productivity also decreases. And being positive, something always added, and definitely this will aid in the results also. So here this is EA upon RT1 minus EA upon RT2. What I have done, just go for a summary. This the equation I have derived, right? Simple equation tha, K is equal to A into e to the power minus EA upon RT. This was the equation, right? I have taken the logarithm, right? And by that logarithm, what it has become, log K is equal to log A into, in that place, plus log A into B is equal to log A plus log B. Since it was power, log of A to the power x always equal to x into log A, it has become minus EA upon RT log E, and from here log E is equal to always 1. We have come to this equation, and log K1 is equal to log A minus EA upon RT1 if temperature is G1 and if the temperature is 2. This is very, very, very important formula for the numerical question. The second numerical question that is asked in the option of the integrated rate law is always this and this only. Right? Kinetics is very predictable. You can predict the questions. I have studied it at least 5 years question paper, and I have seen only these kind of the questions are. So, only the hard work is not the key of success. The smart work, the perfect planning, that is also the key of success. If you want to score good, you must plan the strategy, and this is one very important part of the strategy. If you have prepared the integrated rate law and this, that means your 5 marks are confirmed. So here log K2 upon K1 is equal to, now EA are, I think now you can see these two terms are common here. You can take it common. Log K2 upon K1 is equal to EA upon R 1 upon T1 minus 1 upon T2. This is the equation you have to use. I'm just going to make it more simple. One more step ahead, I'm going to make it simple. If you have to minus 1 by A minus 1 by B, you cannot set the A minus B. For that you need the LCM, right? Primary classes, please do remember the 1 upon 5 minus 1 upon 2. That is a simple thing over here. Log K2 upon K1, this is equal to EA, energy of activation, the gas constant, the what will be the LCM T1 into T2, T2 minus T1 upon T1, T2. These two, this one equation and this equation, either directly you use this, definitely you have to come over here only when you are going to substitute the values. So directly either you can use this or that. These are the two equations that we all use for the numerical purpose, right? Any doubt you are in have? So shall we begin with the numerical? Want to do? Please go. I'm just telling you what kind of the questions are being asked from this chapter, from this particular topic. 2-3 types of the numericals are there. Once what may be given, the rate of reaction may be given, the value of K may be given for the two different temperatures, right? And you have to find the value of the energy of activation. Otherwise, it's vice versa. The energy of activation is given, right? Now, the value of the temperature is given, and you have to find out what will be the rate of reaction at given temperature, or how many times the rate of reaction is going to be changed. One more thing, if you want to make it more easy, you convert into the log base 10. Rather than the natural log, you can take, it's easier to find out the value. And again, my dear students, my loving students, I'm telling you, you need not to be worried about the value of the log. It's always given in the question paper. Whatever the required value will be there, you will always found in the question paper, always will be given in the question. Don't worry about that. Sometimes, especially the bio students, they are having the phobia with the logarithm and the integration and these mathematics. But don't worry. I think earlier also I have told you that this integration and this logarithm is not a rocket science. It's not a big deal. What you have to do, if the math students can understood by seeing love at first sight, right? You can go for the 3, 4, 5 sites, but definitely after that you must. कोई भी चीज है एक बार देखने में नहीं होता, आप उसको 2 बार देखिए, 4 बार देखिए, कब तक देखिए, जब तक प्यार ना हो जाए, तब तक उससे देखिए, जब तक आपको अपने सब्जेक्ट से प्यार ना हो जाए, उतनी बार आप पढ़िए. डेफिनेटली द डे विल कम, यू विल हैव द मास्टरी ओवर द सब्जेक्ट, right? Why we are having? Because we have read it to the uncountable number of the times. That's why we have this passion, we have this love for our subject. So if you are not able to understand, if you don't have developed the bonding in the first sight, you just go for the number of sites as many as you wish, but ultimately you must love it. Okay, so here how you will convert it into the log base 10. You all know that natural log is equal to 2.303 log base 10. Even at the beginning also you could have done it, and even at the end, it doesn't make a difference. Definitely the result is going to be same. If I'm going to convert this, what I have to do? I have to multiply it with the 2.303 log K2 upon K1. Is here any quantity of log? No. So you don't have the right to put the 2.303 directly over here. What you have to do? You have to write EA upon R T2 minus T1 upon T1 T2. Right, now I want to remove this from. What I should do, I must want to divide the equation by 2.303. Right, if I'm going to divide it by 2.303, sorry, I have written the T factor here. And here again I have to divide this side also by 2.303. This will be cancelled out. Now what will be left? Log base 10 K2 upon K1 is equal to EA upon 2.303, right? T2 minus T1, T1, T2. This is another, and generally you use this. So these are the three different form of the equation, 1, 2, 3, right? And now in the very quick session, I'm just going to make you comfortable with the graphical presentation also of this equation, right? Please see here, and tomorrow I will take one numerical question based on this formula, right? Please, by the today, you complete this, you just go through your NCERT book. It's very nicely given over there. So you can learn it from there, or any source you want. You just can see the session revision of that also. You can just see the session again once. Now, I'm just going to tell you about the graph. As you have done for the zero order and the first order reaction. Okay, what I'm going to take here, the original equation, log K is equal to log A, right? What I have taken, log, please go for it, or otherwise if you want to take the last one, that also you can take here, right? So whenever I'm going to take the equation, what you will find, log K is equal to log A minus EA upon RT. Best is to take the last one, last equation, that is far more better. Please tell me where it will go for. You just write it for the log base 10. Please convert this. I am giving you just 1 minute, right? Convert this equation into the logarithm form. Please, you can do it 1 minute only, because I will not get the much time. Please keep in mind, this is a constant, this is a variable. You have to take the variables first, because graph is always plotted for the variables. Okay, I'm going to convert it. Okay, very fast I'm going to do it, right? What will be the final equation that I will get? Log K, right? This will be equal to minus, I'm taking this first because here the variables I have to use, because this will be the, okay, I can write it for the log. Okay, first I'm not skipping the step, log A minus EA upon 2.303 RT, if I have converted it in the terms of the log base 10. Now, since the graph is always plotted for the variables, that's why I'm bringing this here, log K is equal to minus EA upon 2.303 RT plus log A. So here you can compare it with the y is equal to mx plus c that we did in the first order reaction and the zero order reaction. In the y-axis, why you have, what variable you have to take? This variable will be the log K. In this, you can see the variable is the temperature. So the x-axis, this will be the temperature, and Now, since again its value is minus negative, that means again what kind of the graph you are going to get, inclined or declined, you will get this. In the case of zero order and the first order integrated rate law, always you have seen this C was the intercept. So again here, this at the t is equal to 0, this will be intercept, the value will be log A. Now the turn for the most important quantity, that is your slope. The question always asks for the slope. Please tell me. You all know that m is the slope. What is here? EA upon 2.303. So the value of slope will be minus. Please remember the question of last class. 4 graphs I have shown for all the different one, and every time the difference was in the sign also, minus EA upon 2.303 R. So, and if you are going to take it in the natural log, in the terms of natural log, the very short I am going to take, this will be log R, again this will be T, it will be a declined graph, the slope will be minus EA upon R, intercept will be same. So with this, it is the end of the class. Please join me tomorrow at the same time, 10 o'clock. Thank you, and please do solve the questions of this. Tomorrow, I will start my session with one question, numerical, based on this reaction. Thank you. Keep watching, keep learning.